So we're back with exceptions in Java, this time an example, both of checked and unchecked exceptions, as well as errors types that might occur in Java. So I'm going to set a breakpoint here, and we have 5 different methods here that shows all different ways of testing this. I'll set a breakpoint, and we'll run to do something with the file and see what happens. So we get to the breakpoint, trace into, and we immediately throw a file not found exception. Since this is a checked exception, we are required to acknowledge it. So it would not compile if this method was not decorated with throws not found exception. This throw is really part of becomes part of the method signature. The compiler requires it, and it allows us to look at it even from a documentation perspective and see what types of exceptions this method might throw. So we throw the exception, and this is, I don't find the file. And think of a utility method. It's asked to open a file. It doesn't know anything about the broader application necessary. It can just say, I've been asked to open a file, and I don't find it. It throws this file not found exception. So the file not found exception is handled then. And we have to handle it. If we didn't handle it here, then the main would have to be decorated with throws, and then it would be handled by the system. So if A calls B calls C, and C calls D, which throws a checked exception, then every method in that call stack has to acknowledge that it throws the exception and be decorated in its method header like that, or it has to have the catch file not found exception and deal with the exception. The idea is that you'll get, as you go from the utility method and up the utility stack, you get up the stack calls, you get up to a level of code that's more management oriented. That is, it knows the overall process. So in this case, when the overall process is known, you recover in business logic from the file not found. You might recreate the file with default settings. You might check alternative resources. You might ask the user what to do. At the minimum, you always log the exception in case you didn't recover from it gracefully. So you can change the code. So if you're expected by the class designer of the exception and of the library that exception tends to go with, like file not found exception is in the IO exception hierarchy, which is part of the IO library. So it's what that class library's designers thought were something that you could possibly recover from. So I've modified the code, putting example 2 first, and I'll set a breakpoint, and we'll run to that breakpoint. Now we'll trace into, and it's going to immediately throw an exception. This time, it's really the same type of thing as file not found exception. But this is a some application exception. In other words, I define this exception, and we'll look at it later. So as the class designer that designed the exception this goes with, expected me to recover. So I have the comment here, recover the task, and we're going to print this stack trace and terminate. So the exception is caught here. And then none of the exceptions are caught, and then main ends. Let's take a look at the application exception type. So here's the code, and it's pretty simple for the some application exception that we looked at earlier. Notice it just extends from exception. This makes it a type of caught exception, of handled exception. So some application exception extends exception. So the class designer that designed this library that uses this type of custom exception type thinks that the application should be able to recover from it. That is at the business level and recover the task. The next type of exception we're going to see is the runtime exception. So you as a class designer can implement either type. This time, instead of extending from exception, we extend from runtime exception. And this puts this exception in the category of an unchecked exception. That is, it's an exception that's thrown, and if it's not caught, it will terminate the application. But we don't have to acknowledge it with a throws or a catch. We're not expected to. The class designer has designed this as an exception that we're not expected to recover from. Again, you should catch all exceptions and at least log them, because otherwise you'll never be able to fix your bugs. But in terms of specific application correction. The application designer has thought that was impossible if you extend a runtime exception. This should be rare for you to do as an application designer, by the way. Libraries, yes, but inherently you're working at the business level when you're writing your code in general. So I'm back in the debugger with the breakpoint set, and also we're about to execute here. Do something with runtime exception. That's the exception class we looked at a little bit earlier. Trace into, and really the only thing interesting here, we're not required to acknowledge it. It's a runtime exception. We don't have to acknowledge it by decorating our method with the throws. It's not part of our function signature, our method signature. It's caught just the same. And this time I wanted to show, this was a specific runtime exception that I created for this demonstration. I could catch it more specifically, but in this case, I just catch it with using ISA to catch at the ancestral level. I just catch exception, and here we log it here. Okay, let's go on to the next example. All right, we're back in the debugger, this time with example 4 in the doc. Do something bad with arithmetic. So I'll trace into this, and we'll see what's bad. I set up I is equal to 0, j is equal to 10, and then I divide j by I, so division by 0 error. Notice we're not decorated. This is a runtime exception, but we're not decorated with it. And we're not decorated with throws exception is because suppose every time you did arithmetic, you might have an arithmetic exception error. You'd have your code would be festooned with nothing but try-catch blocks. That's really the motivating factor here. And it's no doubt caused by an application bug. You need to retool your code in that aspect. So, not expected to recover from, and if you expected you to recover from it, you'd be festooning your code everywhere with exception handling of this nature. So it's not a checked exception. That's really the cut. So here we are, and it catches it as an exception. Again, it catches it as its base class. Okay, back in the debugger, this time with example 5 at the top, run out of memory. So we'll trace into this. And this is actually going to run, and you can see here's a string builder type, and the string builder in an infinite loop gets appended to, so eventually running out of memory. Let's just run it out. So the string builder is getting bigger and bigger as it takes more and more memory. Then error, and then when we have a breakpoint down here, otherwise we caught it. And this time we're catching an error. And that, remember, that's the other throwable. That's back up to the base class. It's an error. And errors represent, from the Java system designer's point of view, something that's happened serious in the Java runtime. In this case, we ran out of memory. That can be caused by application bugs, as we just illustrated here. This would be let's say an infinite loop that built up a string builder would definitely be regarded as an application level bug. But these types of errors can also come from system level instability. Now, Java is 30 years old, so it's been beat on good. So there's not very many bugs left in the Java runtime, but the system may become unstable from the computer standpoint. Perhaps computer memory is failing or computer disk is failing, that causes instability in the Java runtime. So that can occur. So you're not expected as an application programmer to handle it from the application level. And indeed, at this point, logging may be a little bit shaky as well, because you're having Java system problems, and logging might not even work. But hopefully it does. You'd have to try to log this and then recode your application, or find out what's gone wrong with your Java runtime. So to summarize, we talked about runtime exceptions and showed examples of that, and all of these are derived from runtime exceptions. These are in the Java standard library. We also showed that you as an application developer can create a runtime exception. And again, in runtime exception, you're down a branch that is not a checked exception. It'd be rare for the application developer really to have a good motivation to write a runtime exception. It can happen. For the most part, you want to derive from exception, which makes your exception a checked exception, which requires the application programmer to acknowledge it, and you're expected to recover from it. The other type of Java throwable, people think of this as an exception. It's related directly to throwable, therefore a sibling to exception is the type of error that can occur when something deep in the Java runtime has occurred to cause systematic instability. And again, as an application programmer, you're not expected to recover from that at an application level. At the most you can do is log it and try to correct your code or the hardware system. Thank you so much.